All right, well, hello again, advanced algebra students. Let's go ahead and take a look at today's, which is going to be 14.2, our second day in 14.2. We are going to be looking at solving trig equations. So how do we go about solving these different trig equations, equations that have trig ratios in them? So we have a couple strategies. First, we have a couple different situations. So our first situation is non-calculator. How about the type that are non-calculator ones? What do we do? Well, step one, solve for any single trig expression. So you'll see what I mean. A single trig expression is just one that is just either like a tangent or like a tangent squared. But if you have multiple ones like a tangent and a tangent squared, then you're going to have to do strategy number two, which is set equal to 0 and factor if you have multiple trig expressions. And I'll show you an example of each of those methods. Then with the calculator, we also have two strategies for calculator. One, set the equation equal to 0. That's your first step. And then the second step, graph the equation in the correct window. And then look for the solve then for the zeros. Okay, so those are our processes. Let's look at some examples. If you need more time, just pause the video and copy things down. All right, so first we're going to look at non-calculator examples, and we want the answers where theta is between 0, it can be 0, notice it's theta is greater than or equal to 0, and less than 2 pi. So if the theta of 0 works, then the theta of 2 pi would also work, but we're not going to include 2 pi because we already included 0. All right, so let's look at our first example. First example is number 19. We want to solve the equation 2 times the sine of theta equals 1. So we want to know what angles I could put in for theta that would make this a true statement. So what I'm going to do, this is just a single trig expression, so I'm going to solve for that sine of theta. So to get the sine of theta by itself, since it's multiplied by 2, I'll divide both sides by 2. So I will get the sine of theta is equal to, and if I take 1 divided by 2, I get 1/2. So at this point, what I know is I'm going to have to use reference triangles to figure out what angle theta gives me a sine ratio of 1/2. Well, if it's non-calculator, it means it has to come from a 30-60-90 triangle or has to come from a 45-45-90. And 1/2, you should know that that has to come from the 30-60-90. And so specifically, if you want to draw out your 30-60-90 triangle, you can. But the 1/2, you should be able to figure out, comes from a 30-degree angle. So I know I need to know in the, notice this is from 0 to 2 pi, so that's in the coordinate plane, measured in radians. What angles have that sine ratio? And they're going to be ones where the reference triangle produces a 30-degree angle. So here I'm going to sketch that. So notice, since it's positive 1/2, I know it has to be where this y value, the opposite side, is above. So it's got to be up here, and these two quadrants here can't be down below here. And notice that I want it to be 1/2, so this has to be 30. So I created my 30-60-90 where this is the 1, this is, the hypotenuse, this is the 2, this is the 2, and this is the 1, this is the 2. So I get both of those, I get 1/2. Well, look at what those are. 30 degrees. Well, what's that equivalent of that in radians? It's pi over 6. So if you have to, you can just take 180 and divide by 6, and you get, take 30 over 180, and you get that. And this is 30 away, or 1/6 away from being a full pi. Well, pi minus 1/6 would be 5/6 pi, because 1 minus 1/6 is 5/6. So those would be the angles that we have there. Let's look at another example. So here we have sine theta is equal to negative sine theta cosine theta. So in this case, we have multiple trig expressions. Okay, we've got sines and cosines. So we can't just solve for a single one. So we need to go ahead and move everything from the right over to the left and set it equal to 0. So I will add that sine theta cosine theta to both sides, and so that'll make my left side sine theta plus sine theta cosine theta, and my right side then has nothing, it's equal to 0. So now what I'll do, if I look at my steps, my second step is to, or part of that is to factor. So I will factor out, notice I have a common factor here of the sine of theta. So factoring that out, I get sine of theta times 1 plus cosine theta. Well, in order for this to be 0, either this has to be 0 or this has to be 0. So I am looking for two different things. One, I know the sine theta has to be 0. For this to be 0, this would have to be a negative 1, so I'm looking for where the cosine of theta is negative 1. So first let's look for where the sine of theta is 0. So if we think about that for a moment, think about that's where the opposite side is 0. So the opposite side is going to be 0 when we are either straight along the x-axis. That's where we have no opposite side. So that would be at 0, and then over the negative x-axis at pi. For the cosine to be negative 1, I need the x value, or the adjacent side, to be negative 1. Well, that is also at pi, so I've already included that, so I don't have to include that again. That's just going to be 0 and pi. All right, let's look now at calculator examples. So we are still looking between 0 and 2 pi, which means that when we go to graph it with our calculator, we want our window to be from 0 to 2 pi, or we can go from negative 2 pi to 2 pi, but we want our window to end at 2 pi. So let's go ahead, let's look at how we're going to do this. So here we have 2 tangent theta equals tangent theta plus 5. So what I'm going to do is I'm going to set it equal to 0, so I'll subtract the tangent theta and subtract the 5, and I know that's going to be equal to 0. Now I will go ahead and I will graph that. So taking out my calculator, whoops, didn't want to turn that off, want that on, want that off, there we go. So what I'm going to do with my calculator here, I'm going to turn it on. So I think you should be reasonably familiar with doing stuff like this. So I'm going to go to my graph screen, there, and I'm going to go ahead and I'm going to enter. Notice, make sure your calculator is in radians. Anytime you graph, you need to be in radians. So I'm going to hit my tab there, and I'm going to enter 2 tangent. Now notice when I put this in here, I can't use theta, I have to use x, because all of my functions, notice, are f in terms of x. So I have to use the x variable. So I have 2 tangent x minus tangent x minus 5. And I'm going to go ahead and hit enter and graph that. But notice this is not the window I want. This is my standard window going from negative 10 to 10. So the easiest way to get to the window you want is to go menu, pick number 4 for a window, and you could put in those values, but it's a lot easier just to go down here and hit number 8, zoom trig. Zoom trig automatically changes it from negative 2 pi to 2 pi. So notice as I look here, I'm looking for places between 0 and 2 pi. So I've got 2 places where that happens, here and here. So I must figure out those 2. So this should be something you're familiar with. Hit your menu, hit choice 6 to analyze the graph, and that first one, just hit enter. You want the zeros. So I'm going to go to the left of that 0 and hit enter. Then go to the right and hit enter. And I get one of my zeros. And now I'll go and do the other one. So I'm going to go hit menu 6, enter for zeros. I'll enter to the left of that with a lower bound and an upper bound to the right of it. Now notice the way this puts it, it puts one on top of the other. I don't want that. So I'm going to grab that one there and move it like that so I can see. So now I can see that I've got my 2 answers. I've got 1.373 and 4.515. So here are my answers. I've got my 1.373 and my 4.515. All right, let's look at one more example. So here I've got the sine of x plus 2/3 is equal to the cosine squared of x. Now this is the tricky part here in how we go to enter that in our calculator. So the first thing I have to do is set everything equal to 0. So I will subtract this cosine squared from both sides. So I get our 0 on the right side. So I get a sine x plus 2/3 minus, and notice the way I wrote this. This squared here means that the whole cosine of x is squared. So I put parentheses around this entire cosine of x and put this squared here. We like this notation because we don't have to use parentheses as much. But when we go in the calculator, you must put parentheses around the whole thing and square it like that. Your calculator will not recognize this. So this is what I want to enter in my calculator. So let's go ahead and let's see that in action just so we can get a practice with it. So I'm going to put my calculator down. I want to clear this out. So I'm going to go ahead. I could clear it, or I can just simply go and replace that function with this one. So I know I've got the sine. I put in x plus 2/3 minus, and now I have to put parentheses, put the cosine of x inside that parentheses, and now I can square it and hit enter. And notice I see here I also have two places where I have solutions, right here and right here. So finding those, hit 6, hit my 0, go to the left of the first one for my lower bound, then go to the right for my upper bound. So I see I will be at 0.267 there. And then for my other one, I'll do the exact same thing. Menu, 6, enter. Pick my lower bound and my upper bound. And once again, it's on top of the other one, so I have to move it. Grab it with my little hand. And I see that this one is going to be 2.875. So I can go ahead and record those answers. And I'm done. Okay, so your homework is going to be 14.2. It's 20 through 30, all of them. You can use your calculator on 23 through 25. So that means you make sure you go out to 3 decimal places on those. 23 through 25. The others are non-calculator. Okay, you can find exact answers on those. Those are all stops on your known special triangles. Okay, hope things go well, and we'll have another video for you tomorrow.